Hello everybody, I'm Javad Zolfaghari. My advisors are Bogdan and Just. I'm going to present my work on semi-supervised active learning for image classification. Active learning methods aim at reducing the annotation effort. The key idea behind active learning is that the machine learning model can achieve a satisfactory performance with a subset of training samples if it is allowed to choose which samples to label. We are inspired by the empirical study in the context of forgetting in deep neural networks. The authors defined forgetting event to have occurred when an individual training sample transitions from being classified correctly to incorrectly over the course of learning. They found out that the most important samples tend to be those that are forgotten the most. Since in active learning we have no access to ground truth labels, we need a criteria to measure the forgettability of samples. To this aim, we propose to use dispersion of samples. Based on this measure, we compute the deviation from the mode of predictions in the course of training. We also consider entropy to measure uncertainty of unlabeled sample. We performed experiments to compare the amount of unknown samples that are queried by dispersion and entropy measures. These experiments show for any budget size, dispersion measure gives more unknown sample than entropy. In semi-supervised active learning, the aim is to take advantage of large amount of unlabeled data to improve the accuracy of model that only has access to a small number of labeled examples. These methods focus on not only the uncertain samples of low confidence, but also high confidence samples that can be selected and iteratively assigned pseudo-labels. This simple yet effective method is proved to boost the performance of classifiers. We introduce a novel active learning framework consisting of two models in such a way that the main model is only trained on Oracle labeled samples and the auxiliary model trained on both labeled and pseudo-labeled samples. In this framework, the auxiliary model, which has seen more data, helps to query more challenging samples to the Oracle, while the main model remains immune to the possible errors in the noisy pseudo-labels. Our experiments show that using dispersion and entropy measures in our framework gives classifiers that surpass the performance of the state-of-the-art pseudo-label based framework on Cypher 10 and Cypher 100 datasets. Recently, the magnitude of gradients with respect to the parameters in the final layer of the network are used to measure the uncertainty of samples. For the future work, we are willing to study the gradients of all the intermediate layers over unlabeled samples to query the most informative samples. As a personal challenge, I would like to find an active learning method that is generally performing as well as the best baselines while remaining robust to architecture choice and dataset.